deviation, taking our data and looking at it on a symmetric distribution. So I want to talk about how to set up using your calculator, but understanding just looking at a picture and how that helps you at least get a general idea. I wouldn't just use my calculator initially, or you won't really know if what you entered was wrong. So I always make a curve, and if we know the mean and we know the standard deviation, just make sure you make sense of that. Standard deviation is 5. Sometimes it will list our data list, like we'll say X N as mean of 60 and the standard deviation of 5. You notice it's not 5 squared, but that's how the notation shows up sometimes, just so you know that. So if I'm looking at standard deviation, I know one standard deviation above would be 65 and one standard deviation below would be 55 because the standard deviation is 5. Two standard deviations, 70 and 50. I think it helps to get a little perspective there because you'll have an idea then if your answer makes any sense. So from 60 to 65, they want to know what is the probability. So what is the area between 60 and 65? What is that? Remember, the whole area adds up to 1, so what fraction of the area? So to do that, we have two distribution things we can use. We can use normal CDF or we can use inverse norm. Inverse norm is when you know the probability. Normal is when you're trying to find it. Okay, so right now I have it starting at 0. This is how we enter 0. And I want to go from 60 to 65, and my standard or my average is 0 or is 60, and my standard deviation is 5. Now before you hit enter, we already know the answer to this because we have talked about this. One standard deviation is generally 34%. Okay, 68% on either side. So 0.341 is the probability. Okay, so now looking at, let's change in the picture again from 62 to 67. So for that one, I'm gonna just make another little mark here. So I know whatever my answer is, I'm gonna get something that's a little bigger than what I had before. The probability should be a little bit higher because it's a little bit bigger of a range. So thinking about that ahead of time, and if you don't have the TI-84, you enter this stuff the same way. You just got to put the numbers in with comments. So lower bound, upper bound, mean, standard deviation. So I'm gonna hit second enter, and I'm gonna change, instead of 60 to 65, now I'm going 62 to 67. You certainly can go back to the place where you started it, but the other stuff stays the same. Okay, and so I go, oh, wait a minute here. Between 62 and 67, that area is smaller. What happened? All right, well, I'm going to check. 62. No, that's because I put it wrong on the picture. And so this is a place I did not actually set it up that way. This is a place where making the picture can help you because my answer did not make sense. So I go, oh, I put it wrong on the picture. Lower bound 62, upper bound 67. Should probably go get another cup of coffee. 0.263. 264, 2638 is 264. Okay, now less than or greater than 64. There's a couple ways you can do this. You can just find 64, or you can go 64 to a really big number. Okay, so 64 is right in here to a really big number, 0.21. If you did from 0 to 64, 0 has to be 1 times 10 to the negative 99, something really small. If I went from 0 to 64, same information. you notice I get 0.788 because my calculator gives me everything that is less than or equal to my number. So 64 is right here. The probability section is 0.788. So if you subtract 1 from that, you get back to where our answer was, the 0.212. Okay, so again, understanding the where you're at on this helps you see. So 68, I know is going to be up here. Everything less than 68, so I can go from 0 to 68, 94.5. So 0.945. Okay, let's go over to this side, and this one is, we call it quantiles or k-values, but basically they're giving you the probability. It says illustrate with a sketch, giving you the probability, and you're finding what is the actual value where this would happen. Okay, so I'm going to make a sketch, and I have a mean of 20 and a standard deviation. Sigma is 3, and it says 3 squared, but that's just how the notation is. So this time I'm going to use something called inverse norm. Now, before I do that, I'm going to do my little thinking here. I know that 0.348, my answer's got to be somewhere down in here, because this is 0.5 is to the middle. So I know I'm below 20, and I got to figure out where I'm at below 20. So I'm going to do inverse norm. Bye, Mr. Duel. And I'm going to enter the probability they give me, 0.348, and the mean is 20. Standard deviation is 3. And so 18.8. So again, in case you couldn't see that, inverse norm, area, mean, standard deviation. If you're using a non-TI-84, you just do inverse norm and type those 3 things in right there. Okay, so my value 18.8, I'll make it a little closer, is the K value. So this one says find a number that X is less than K. So again, we're looking at less than 0.878. So I know that's bigger than 50%, bigger than half. So I know it's going to be over here if my mean is 20. I can make it go from 0 to, or I can go to my distribution, go to inverse norm, enter 0.878. Still same data, 23.5. Makes sense to me. I'm good with that. Again, the picture helps. You saw the big error that happened before. 50% is going to be right on the mean. Because, again, saved yourself some time. There's that picture there. So, just to review, Normalcdf, lower boundary, upper boundary, mean, standard deviation. This is mean. When you see that little squared thing, ignore it. On any calculator, you can do it that way. It'll sometimes be a little easier to enter. So this is when you know the range between. Here is when you know the probability. Probability would be inverse norm. And you put the probability and then the mean and the standard deviation. So probability mu sigma. And basically when you go to enter one in, and if you don't have the right information, try the other one, and that will help you keep those straight. So you can finish this. The answers are on the back of the paper if you're in my class.